Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous video, we have defined polymer in a proper way and we have seen the classification of the polymer based on their availability of sources as natural polymer and the synthetic polymer. Well, then we have seen the classification based on the structure of monomeric chain as linear polymer. If you have missed that video, you can find it in the I button on the top of the screen. Now, in this video, we are going to continue our classification of polymer based on the monomeric chain of the polymer. In this, we are going to see the branched chain polymer. Well, these branched chain polymer are basically natural polymer, or we can say basically linear polymer. But they have certain branches on the backbone of the linear polymer. So if this line is the linear polymer, then this is the branch on the linear polymer. So combinedly we can say that this is the branch polymer. So here in the screen you can see that this polymer which are mainly linear in nature, but they also have some branches along with it. So we can say that this branched chain polymer are basically linear polymer, but they have sub branches attached to their backbone. Now, due to this irregularity or poor packing of the structure, this branched chain polymer have very low melting point, they have very low strength and tensile force. So it is very easy to understand that the monomer in this particular polymer are very apart from each other. So they are not tightly packed, so they will have lower density than the linear polymer. Now their example are low density polyethylene, then we have glycol and starch. Basically, their monomer are relatively apart from each other and that causes them to have low tensile strength and low melting point. Well, it is not that much difficult to understand that since their monomer or their tiny component are relatively apart from each other, their volume will be larger. So we can say that the branched chain polymers have higher volume due to their repulsion forces between two adjacent molecule or the monomers. Well, this is the main reason that this polymer has relatively low density and low tensile strengths. So we can say that they have low density and low strengths. Here in this image, you can see that the branched chain polymer. Here you can see there is a single chain of a linear polymer and certain branches are attached to it. Now let me just take a pointer so that I can explain you this thing in a more clear way. So here you can see that this is the linear chain and these are the branches attached to it. So we can say that this is the branched polymer. Here in the polyethylene example, you can see that this is the straight line chain of the linear polymer and these are the branches attached to it. So this was all about the branched chain polymer. Now let's continue further this classification to the crossed link polymers. Well, as the name suggests, these polymers are crossed link with their backbone. So they are composed of basically bifunctional and trifunctional monomer. Only this bifunctional and trifunctional monomer can form this crossed link network of this polymer. So they are basically composed of bifunctional and trifunctional monomers to form three-dimensional network of complex structure of this polymer. They have relatively strong covalent bond between their monomeric units. Bakelite and melamine are the classic example of these cross-linked polymers. Here in this image, you can see that these are the cross-linked polymers. Now, let me just take a pointer so that I can explain you this concept of the crossed link. Here in this image, you can see that this is the straight line of the linear polymer and this is the branch of it. But this branch is attached to the another straight line or a linear polymer, so that we can say that this is the crossed link polymer. They are linked with the another chain of the polymer in a cross manner and they are forming the complex network of three dimension. So this was all about the classification of the polymer based on the structure of monomeric chain. Now let's just continue our classification of the polymer based on the monomer. So we can classify polymer based on the monomer in different categories. First is the homopolymer and the second one is the copolymer. Well, as the name suggests, these are the homopolymer, which means they will have the similar kind of the monomer that is joined together and combined with the covalent bond to form the structure of the polymer. Polymer which are formed by repeated combination of only one type of monomer is referred as the homopolymer. Here in this screen, you can see that the example of such homopolymer, such as polyvinyl chloride, then we have polyethylene, polystyrene, polyvinyl acetate, then Teflon. So these are the homopolymers. Here in this image, you can see that the structure of the homopolymer, where you can see that this pink section is the basically same or the repeating monomer that is joined together to form this homopolymer. In this structure, you can see that we have used this styrene. So this styrene monomer is continuously repeating to form the polymer called as polystyrene. This was so now having said that, let me move to the copolymers. Well, these are the copolymer or heteropolymer. As the name suggests, these are the polymer that are joined with the two or more than two monomers. These are the polymers which are obtained by repeating combination of two or more than two type of the monomers. And their example are Buna S, Buna N. Here in this image, you can see that the typical structure of this copolymer or heteropolymer. Now, let me just take a pointer so that I can explain you this thing in a more easy way. Here in this image, you can see that this is the one monomer and this yellow object is the another monomer. So these two monomer are completely different, but they are combining to form the long chain of the polymer. And this referred as the copolymer. So here in the structure of this Buna S, you can see that we have used 1,3-butadiene and another monomer we have used is this styrene. So when these two monomer combine together and produce long chain of the polymer that referred as the Buna S. Well, this is not the end of the story. We have further classification based on the monomer as the random polymer, alternative polymer and blocked polymer. So here in this screen, you can see that we can define random polymer as these are the repeating unit are arranged in a random manner on the chain of the molecule. For the repeating units having A and B, the random copolymer might have a structure like this. Here you can see that this structure has the two monomer A and B. Both are arranged in a completely random manner, where you can see that this AA, BB, then they are alternatively. So we can say that this is the complete random copolymer. Well, you can see this in this image as well, where the red marble is one monomer and this black marble is the another monomer. You can see that they are arranged in a completely random manner. So we can say that this is the random copolymer. Now having said that, let me introduce with the alternative polymers and block polymers. So, an alternative copolymer is the polymer comprised of a two different monomeric unit distributed in alternative sequence. So, here in this image, you can see that the red marble and black marble are arranged in the alternative manner. So, these are the alternative copolymers, or we can say that these are the alternative polymers. The arrangement of this A monomer and B monomer in a such a way that form the alternative polymer, such as AB, AB and AB. So these are the alternative polymers. Now let me introduce with the blocked polymer. So here the second image is for the blocked polymer. And blocked polymer or a copolymer is referred when two monomer clusters are joined together to form block of repeating unit. So here in this image, let me just take a pointer so that I can explain you this thing in a more easy way. You can see that here this black marble are arranged in a one block. Then it is followed by the red block of the marbles. So here in this image, we have first all the A monomer, then we have all the B monomer, then again this B monomer is followed by block of A monomer. So we can say that these are the blocked polymer. And here in this alternative copolymer, you can see that here the first is the black marble, then we have red marble. So basically it is arranged in an alternative fashion. So these are the alternative polymers. Now, having said that, let me introduce with one of the most important polymer, that is the graft polymer. Well, this graft polymer sometimes asked in 1 marks in your university exam as well. So basically here in this image you can see that this graft copolymer is a type of polymer in which one or more than one blocks of homopolymer are grafted as the branch on the main chain. So here in this image, let me again take a pointer. So here in this image, you can see that this is the straight line of the single monomeric unit, in which these are the different branches of the same or different homopolymer are grafted on it. So we can refer it as the graft polymer. Here you can also see that these are the A polymer which are lined in a linear fashion, onto which different branches of homopolymer are grafted. These are the B, then this is the C, then here we have alternative fashion. So this all can be referred as the grafted polymers. So this was all about the classification of the polymer based on the monomer. We will see you in the next video. Till then, keep watching, keep learning. Thank you.